This question is telling us that a ball is randomly picked from a bag that has 4 red, 2 white, and 3 blue balls, and that another ball is picked again from the bag after it. Notice how there's a huge bold in is not replaced, so we better keep this note in mind. The first part of this question asks us to draw a tree diagram on these two rounds with all the possible branches. Let's start drawing the first round of the experiment. 3 possible results will happen. You'll either get a red, white, or blue ball. So let's create 3 branches and label them red, white, and blue. Next, we will have to figure out the probabilities of these 3 outcomes happening. If we add the red, white, and blue balls, we'll get a total of 9 balls. Out of the 9 balls, the chances of getting a red ball is 4 in 9, a white ball is 2 in 9, and a blue ball is 3 in 9. Now that we have figured out the probabilities down, just label each respective branch with them just like this. We have finished the first round. Before we start drawing the second round, remember that the question said the chosen ball is not replaced. And since a ball is taken away from the first round, there will now only be a total of 8 balls. In addition to this, you will also have to consider the color of the ball that was removed. You will see that it will result in different probabilities in the second round. Let's start off with the branch where a red ball was chosen in the first round. Since a red ball was removed, there will now only be 3 red balls left, with a total of 8 balls. Therefore, the chances of getting a red ball in the second round is 3 in 8. Since no white or blue ball was chosen, their numbers will remain the same and will receive the same numerator as in the first round, with the only difference being that there are only 8 balls left. Moving on to the second branch where a white ball was chosen, since a white ball was removed, there will now only be 1 white ball left. Therefore, the probability of getting a white ball in the second round is 1 by 8. And again, because no red ball or blue ball was chosen, or blue ball wasn't chosen, their number will remain the same and will receive the same numerator as in the first round, with the only difference being that there are only 8 balls left. Finally, for the third branch where a blue ball was chosen, there will now only be 2 blue balls left since a blue ball was removed from the first round. The probabilities of getting a blue ball in the second round would be 2 by 8. Because no red or white ball wasn't chosen in this scenario, their numbers will remain the same and will receive the same numerator as in the first round, the only difference being that there are only 8 balls left. Now we have gotten all 9 possible outcomes from the experiment. Let's just label them like this for each branch. And we have drawn a tree diagram. Let's move on to the next part of the question where they want to know the probabilities of the following scenarios. For getting 2R, we can just express it in a different way like P, R, and R because the statement basically you receive a red ball for both rounds. From the rule of thumb we learned in the previous video, if there's an AND in the statement, you will have to multiply both probabilities. You can see from the tree diagram that the probabilities of getting a red ball in the first round is 4 by 9, and the probability of getting a red ball in the second round, if we got a red ball earlier, is 3 by 8. When you multiply 4 by 9 and 3 by 8, you will receive 1 by 6. Moving to the next required probability, to find the probability of getting the red first and then blue second, you just have to reference the tree diagram again. The probability of getting a red ball in the first round is 4 by 9, and the probability of getting a blue ball in the second round, if we got a red ball earlier, is 3 by 8. We will obtain 1 by 6 for the probability as well. The next 2 parts are where things get tricky. They want us to find the probability of getting a red ball and a blue ball. You might be tempted to just write the probability of getting a red ball first, then a blue ball later. However, you have to consider that they just want the chances of getting a red and blue ball, so the order in which the colors come does not matter. We will also have to take into account of all other scenarios that will give us a red and a blue ball, such as getting a blue ball first, then a red ball later. Now that we got these 2 possible scenarios in mind, we can rewrite the statement as P, R, and B, or B and R. We know from the rule of thumb that since there is an OR in the statement, we will have to add those 2 probabilities. You can see from the tree diagram that the probability of getting a blue ball in the first round is 3 by 9, and the probability of getting a red ball in the second round if we got a blue ball earlier is 4 by 8. When we multiply them together, we will get 1 by 6. We already know from part 2 that the probability of getting a red ball first and a blue ball later is also 1 by 6. When we add those two together, we'll receive the answer of 1 by 3. And finally, the question wants the probability of not getting a white ball. If we look at the tree diagram, the outcomes where a white ball is not drawn are these 4 scenarios. We'll just have to add all those 4 scenarios after figuring out each of the probabilities. Just pause the video if you want to work on it yourself, since this is just the same concept we have learned and I will only show you the answer. Okay, so the probabilities of each of the scenarios will be like this, and when we add them together, we will receive the final probabilities of 15 by 24. And we have solved this question. We have also reached the end of this unit. See you at the next one.